This is about function transformations. I'm going to go over a little cheat sheet that I have posted, and then also the homework assignment that I gave for that. So function transformations, I like this one. It talks about two different functions. It's showing, and in the light gray, you can see where the original function was, and then the equation is going to show how the graph moves. So if we have a function and it's based at the origin, when we add something to the outside of the function, it moves it up and down along the y-axis. Remember, that is because we are working with this function of f(x). F of x really is our y value. So our function equals something. It's really a y equals something that would then have this variable x in it. So maybe x and then plus 2. So this is the same as a linear equation. If x is equal to 0, then our y-intercept is 2. So it's telling us how we move it. So when we add a number on the outside, when we are not addressing our x value, in our actual equation, it moves it either up or down. A positive value moves it up into the positive range of your y values. So these are positive y's. A negative value moves it down into the negative values of y, just like with a linear equation. Remember, f of x is another way that we are writing the whole other part of that y equals equation. So we are dealing with the actual equation part here. Okay, so just as when we were dealing with a linear equation, if we have something like this, it tells us that we are actually moving our x value. So when we are adding the constant or adding a value to the x value, we are moving the x value. So there's a difference. We are adding the constant here to the entire equation, which the equation is our y equals. So we are adding the constant to our y value, what will determine what our y value will be, which is why it moves it along the y-axis. Here we are adding, inside the parentheses, we are adding our constant to the x value. So it will move your graph or your function along the x-axis. So adding a constant actually moves it towards the negative x's. Remember, that's because if we set this equal to 0, x plus c is equal to 0, when we move our c over, our constant, our x is now a negative value. So when our y equals 0, which this whole thing says y equals 0, then we can set the inside part equal to 0. So that gives us our x equals a negative value. That's why if it's a positive, it moves it negatively. So in the same way, if it's a negative, if we set this, negative equals to 0, x would equal c, that would be a positive c. So it's going to move your x in the positive direction that way. So this is addressing specifically the x value only. These are addressing the y value because f of x is really our y equals. Okay, so let's look over. In this case, here's our little gray line for this is our original function. Here, when we have a negative for only the x values, so we are confining our negative to just the x values, our y values stay the same. So if we were to plot our points, our y values are going to stay the same, but our x values, if they were positive, are now going to be negative. And if they were negative, they would now be positive because we are only changing, we are flipping only the x values. In this case, our negative applies to the whole function. So if we were to rewrite function of x, remember f of x is really our y value. Technically, we now have a negative of the y. So our x values remain the same, but our y values that we get are now negative. So we are now reflecting across the x-axis. So where our y values were positive, now our y values are negative. Remember, so on the inside, if it's addressing x, we're going to now have negative x, or the opposite x values. If it's addressing the entire one, that is the y. So we're dealing with the y values. Okay. In this case, R2 is addressing our entire equation, right? Because our fx is really our y equals. So R2 is addressing our entire equation. So just like when we had slope, when we have 2x plus 3, our slope here was 2 instead of 1, so it made our line steeper. So in this case, we now have a 2 times our y value. So it's going to make it steeper, or it's going to stretch it. So we are stretching, instead of now going over 1 and up 1, we're going over 1 and up 2. So we are stretching it along the y-axis. Okay, so we're going to be pulling it up skinnier. In the same way like when we did with slope, when it went down, it made our line go wider, or when we dealt with quadratics in parabolic functions, when they were less than 1, they were wider because it stretched them out. When we have a number less than 1, it will smush it, or it will shrink it. So we've got one that stretches and one that shrinks it. So now we're taking our original one and we're shrinking it down closer. We're shrinking our y values down. So in summary, we have this little summary thing. You can keep that. This is the explanation of our function transformation sheet.